Hello, this is Mrs. Brown, and today we're going to talk about the quotient rule. So if you take a look at if you're using the notes and having different columns, the first column is skill, you're going to write the name, which would be the quotient rule. What is it? For every non-zero number, so a number not zero, and integers, so no fractions or decimals, m and n, a to the m power divided by a to the n power equals a to the m minus n. Now think about it, the product rule said we were adding when we were multiplying, and now we're doing opposite, we're dividing, and so we're subtracting. And so it's kind of the inverse operations you can see with the rules. So when do you use it? When dividing powers with the same base. Again, notice they use the same variable for the numerator and the denominator base. They have to be the same in order to do that. So you can pause and take notes. I'm going to move this because I want to show you again why this works, okay, before I even do the examples. So let's say I have something like 4 to the 5th divided by 4 to the 3rd power, okay? If I were to write that out, what that means, that would be 4 times 4 times 4 times 4 times 4, and this would be 4 times 4 times 4, because it's 3 4s multiplied and 5 4s multiplied. Well, if you remember things like simplifying fractions, like if I have, say, 6 over 8, and I write this as 2 times 3 and 2 times 4, I can simplify out the 2's, and so I'm left with 3/4 when I'm simplifying it. So when I go back and use that same idea here, these 4's are going to cancel, these 4's are going to cancel, and these 4's are going to cancel. All I'm left with is 2 4's, or 4 squared. So in other words, 4 to the 5th divided by 4 to the 3rd is the same as 4 to the 5th minus 3, or 4 squared. Okay, and so that's why that works. So on your notes, again, if you go to where it says examples, let's take a look at some examples and what that might look like. So if I say have 3 to the 7th divided by 3 to the 3rd, that's going to be 3 to the 7 minus 3, which would be 3 to the 4th power, and that would be my answer, okay? If I have a to the 8th divided by a to the negative 2, that's a to the 8 minus negative 2. Well, minus a negative becomes a plus, so that's a to the 10th. So that rules apply there as well. Another way to look at that is if we flip that into the numerator like we would with our negative exponent property, it would look like that because the negative tells me to move it up. And then I would be using the product rule instead. And so it would be a to the 10th that way. So that's another way of looking at that same problem because it's a little bit weird with the negative involved in it. Okay. And finally, b to the negative 2 divided by b to the 6. Okay. This would be b to the negative 2 minus 6, which would be b to the negative 8, or 1 over b to the 8th, if we were writing it that way. Okay, so as you're taking a look at it, again, just using subtraction, the bases are the same, and I'm dividing. So when not to use it, okay, you're going to have to pause this because I need more space for this. So I'm going to erase. For this last category, this is the most common way that people have trouble with this particular skill, okay? So you're not to use it when there are addition or subtraction signs. So for instance, x to the 5th divided by x to the 4th plus 1 is not equivalent to x over 1. You can't do it because of this plus sign. It has to be all multiplication on the top or bottom in order to do it. In other words, there has to be one term here and one term here. You can't have it with an addition problem in between because it's not going to work. Okay? I hope this helps and have a fabulous day.